Okay, thank you, Mr. Luckner.
Yeah.
Well, there's nothing, I mean, we're starting new right now, so this is implicit differentiation. All right, here's an implicit differentiation. It may be a test question. 5xy minus y cubed is equal to 8. Okay, now I want you to go, okay, there's been a bunch of cyber attacks. Yep, I wouldn't doubt it because, like I said, and in fact, yesterday afternoon, after I got back from the hospital, after my 2 or 3 hour extent to the hospital, my whole wireless and my direct went out. Well, the direct was dependent upon the wireless. My wireless was out like an hour, so I don't know what's going on.
It's them Russians.
And my wireless, yeah, it's the Russians. After November, everything will go back to normal, even though I don't think November will give these people what they want. I don't think that's going to happen. I think a lot of things will go back to normal after November. All right, so if you want to pick the 5y, if you want 5x, you can, the 5 can go with the y, it doesn't matter. I'm going to do first, I'm going to put this in brackets for you. Again, Calc 1 is where you pick up the mechanics, the basic mechanics for derivatives. I'm showing you the basic mechanics. I'm drilling in your brain the basic mechanics. I'm not trying to get you to be a theologian, okay? So with that being said, I'm going to put the brackets right down here. And I'm going to use the 5x first times the derivative of the second plus the second times the derivative of the first. And we'll do that on the next step. Minus y to the third prime equals 8, 0. Go ahead and take the derivative of that 8. Okay, I'll go ahead and write this as y to the third prime. Now let's go ahead and 5x times 1, the derivative of y, right here, derivative of y is 1, and then y prime, plus y times 5, close bracket, minus, what's the derivative of y to the third?
3y squared.
3y squared, Hubert. Good job, class. And y prime. Now, if you were not here the other day and you didn't watch the video, then you probably have no idea what I'm talking about unless you've had it before and you remember it. But whenever you take the derivative of y, you have to put a y prime beside it. Now, if you want to put d dx dy beside it, you can. If you want to put dy dx beside it, you can. I use y prime. Now I'm going to clean it up. And I'm going to get 5x y prime plus 5y minus 3y squared y prime is equal to 0. And that negative 5y is going to come over here. And that's going to give me 5x y prime minus 3y squared y prime is equal to negative 5y. I'm going to factor out y prime. And that's going to give me 5x minus 3y squared. And that's going to give me a final answer of y prime is equal to negative 5y over 5x minus 3y squared. Now, the reason I would put this one on the test is because it has everything in it. It's got the power rule, it's got the product rule, so it doesn't have the chain rule, but it has the implicit differentiation, of course. So you got 3 things right there that's in this one problem. Got it? Since we got a lag, tell me, make sure that y'all got the answer down. For all I know, I'm in the middle of the problem. I don't know.
You're good right now.
Okay.
Yeah, I'm good.
That's another good test question. Here's another good test question. Now, it's a good test question because you could do it 2 different ways, and it puts the trig in here. You got to have that trig. Tan of xy. Put parentheses there and maybe help y'all out, give y'all a hint, equals 7. Of course, some of y'all are going to what from the get-go? Quit?
Yeah, I quit. I don't deal with tan, sin, and cause.
Yeah, just quit.
Can't do it.
I make a 80 on the test. 80 is good with me.
Exactly. You need just 80 to 90. That's all you need.
80 to 90. I don't have to do that one. Actually, it's not very difficult because this is a question that I use often in my classes because it's one of those questions that you think, oh my God, I don't want to do that one. Let me just go to the next problem. And all you got to remember is the product rule and the derivative of tangent is secant squared. That's it. Because it's implicit differentiation because it's xy, not x. If it was x, then it'd be secant squared, blah, 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 but it's not set up like that. So what I'm going to do is I'm going to take the secant squared of xy, and I just took the derivative of tangent. And that's in concrete. I can't do anything with that. That's it. I'm done with that. But what have I got to do after that? I've got to take the derivative of what? What's inside the parentheses. So I've got to use the product rule and take the derivative of what's inside xy. So I'll put that in brackets right here. And I'll do 7 for y'all. The derivative of 7 is 0. Okay, here we go. First times the derivative of the second. And a lot of people wonder why I use these colors. Because if I'm putting it in black, usually the black means that I can't take the derivative of it or I'm not supposed to take the derivative of it. So that's why I leave a lot of stuff in black. First times the derivative of the second plus the second times the derivative of the first. see, this gets a lot of students right here. They want to take the derivative of that y again. And you can't do that because it's in black. So secant squared of xy, parentheses. Okay, the x is in black, so I can't do anything with it. Y prime, I'm going to change that to, I want to use green. No, I've already used green. We'll do 1, derivative of y is 1, and then y prime goes with that because I'm taking the derivative of y in respect to y. Plus y in black means I can't touch it. And then the derivative of x is 1. And now it's 100% algebra. Lord have mercy, I need something. I need a baton with different colors. I can just swing it around. So the secant squared of xy, parentheses, xy prime plus y is equal to 0. Now we got a problem. The y prime is in the concrete block. So we're going to have to bust that concrete block up with the what law?
Distributive.
And that'll bust that concrete block up. So xy prime, and if you notice I'm not using any colors, that means calculus is done. And y'all can count up. It's about, in this problem, if you count it out, probably about 20%. I don't let y'all forget that. Secant squared xy plus y secant squared xy is equal to 0. Now I'm going to go back in here and I'm going to highlight this guy because that's who we're wanting to get by himself. So I'm going to subtract the y secant. And that's going to give me x y prime secant squared xy is equal to negative y secant squared xy. And now I'm going to divide by x secant squared xy. Oh my goodness. What happens? Anybody?
The secant squared cancels out.
Isn't that amazing? And you're left negative y over x. Now, why would I put this on a test? Well, as you can see, it's not very difficult, but you got to know the mechanics. The mechanics are, I see something in parentheses. If I see something in parentheses, I'm going to have to use the product rule. That's what I'm trying to get everybody to see. Those mechanics. Now, I will say that you can use another method at this point right here. Anybody know what method, another method? Method 2, another method you could do here? What's the opposite of the distributive law? Distributive of multiplication. What's the opposite of distributive law? I just gave y'all a cue. That means y'all need to answer. I just kind of, gave y'all the answer. Y'all just got to deduce it. I said the opposite of multiplication, the opposite of distributive law, which is multiplication, is what?
Factoring.
I can't do mumble.
Factoring.
Factoring, which is what?
Division.
Division. And you can divide both sides by the secant of xy. And the 0 will cancel out the secant. And then you'll be just left with this. You see? Just in case you don't see, I got it written down for you. There. Now I'm showing you this because I want you to see that once you get y prime, once you get it in the problem, there's several different ways you could solve it. Just like there's several different ways you can solve an algebraic equation. You can distribute the 2 with the x plus 6, or you could divide by the 2, and the x plus 6 will just drop down. Again, these are problems that I would put on a test because they test to see if you've got the basis, the basics. I'm not seeing if you could write a calculus book at the end of Calculus 1. Y'all ready? Here we go. 36 is equal to the square root of x squared plus y squared. All right, do that one.
Hello, how are you?
And then I want you to take the double derivative. I might as well forget that. I might forget that, right? Got a radical, and then you want me to give the double derivative? Yep. I'm willing to bet money that some of y'all won't even try the double derivative. How do we start this problem?
Rewriting it.
Rewriting it. Good job, because radicals and calculus do not mix. 36 squared is equal to this squared. Now, I could care less what I get on the left-hand side because it's going to be a what? What is this going to always turn out to be? A number, right? And what is the derivative of a number?
0.
0. So no matter what you get over here, it's always going to give you 0 when you take the derivative. So I'm not worried about it. Over here we get x squared plus y squared. And if you take the derivative, we've done this before, that's not the problem. The x squared plus y squared, you solve it, you get y prime. Y prime is equal to negative x over y. Okay, now I want you to find y double prime. We'll do that over here. Give me the prime, give me the derivative of this function. Of course, that's in respect to y. So it's going to be implicit quotient rule. I hope y'all are working on it. I can't see y'all working on it, but okay, so here's my y prime. Y prime is equal to negative x over y, and I want y double prime. So that means I got to take the derivative of negative x over y. So I get first our denominator times numerator prime minus, I'll put that in red, minus the numerator, negative x, times the denominator prime, over denominator squared. Okay, that's going to give me y.
You have the other ones.
And what's the derivative of negative x?
-1.
Negative 1. I'll put that in pink. Minus negative x times 1 times y prime all over y squared. I'm just going to clean this up a little bit. That looks like negative y via plus x y prime. Okay, some of y'all that's had implicit differentiation second, what are we going to do next? Well, we have y prime right here. Y prime is equal to what? Negative x over y. So I'm going to rewrite this, and I'm going to use another color, and my computer is going to mess up. Let's use orange. Is Clemson color still going to be orange? Okay, so negative y plus x times negative x over y over y squared. And this is y double prime, y double prime, y double prime. And go ahead, this is nothing but algebra. Go ahead and finish that out. You got kind of a, let me go ahead and say that you got a complex rational expression. So that means I'm going to write everything as a fraction. Y double prime is equal to negative y over 1 minus x squared over y squared over 1. What's the common denominator of 1, y, and 1? Y, Hubert. That's right, class. So I'm going to multiply everything by y over 1. And that's going to give me, remember, this is all algebra stuff. Algebra tricks. Negative y times y is negative y squared. Y's cancel, minus x squared, all over y to the third. And that is your second derivative. Y double prime is equal to negative y squared minus x squared over y to the third. Yes, you can turn that around and make x come first, but it doesn't make any difference to me. That's a good test question. Why is it a good test question? Well, for one, you're taking implicit differentiation. 2, you're using substitution. 3, you're using complex rational expressions. It's testing you. This is for the student that needs to be tested on algebra. If you can handle this problem, you can handle pretty much any problem I give you on the test. If you're asking yourself, what planet are we on? After I did that problem, and chances are you need to work on some more algebra. This is where I usually lose people right here, because they don't know where the y over 1 come from. Well, the common denominator of 1, y, and 1 is y. Just like if that was 2, 2, and 4, what's the common denominator of 2, 2, and 4? 4. What's the common denominator of 3, 7, and 3? 21. So the common denominator of 1, y, and 1 is y. That's the end of algebra 2 right there in the red. When you do bad in this class, I don't want you to blame it on the calculus. I have so many students that have done that to me when they walk into my classroom first week. I just suck at calculus. I can't pass the class. No, you don't suck at calculus. You suck at algebra. All right. So I don't know if we've done this one before because I've got it on the back. So I don't know if we've done it before or not, but let's see. If we have, let's just do it again. X plus 3 plus y to the third minus xy is equal to 1. Some of y'all some of y'all that, one or two of y'all that actually take notes. I know most of y'all don't, but check it and see if we've done that one. I was looking to see what time it was, 14. Okay, nobody said we've done it. Nobody said we hadn't done it. Thank you, class. I appreciate y'all's participation. And for y'all, like, just go ahead and do it. I don't want to look back in my notes. I would have to turn pages backwards. X plus, and I'm just going to go ahead and put that. I'm going to say y to the third prime minus brackets first times the derivative of the second plus the second times the derivative of the first equals 1. And I need to put this in pink because I got to take the derivative of that. So that's going to give us derivative of x is 1. The derivative of y to the third is 3y squared, and then a y prime beside it. And I need to take the derivative of that 1. Okay, first times the derivative of the second. The derivative of y is 1, but I got to put that y prime with it because whatever I take the derivative of y or the derivative of the other variable, I have to, because when you're in diffie q and second derivative or second calculus up, how many dimensions are we talking about? 3. So you not only you take the derivative of x, but then you take the derivative of y in respect to y and z in respect to z. So you're going to have a y prime and a z prime. Y, and the derivative of x is 1. Now the colors are gone, so that means the calculus is gone. 1 plus 3 y squared y prime minus x y prime minus y equals 0. That y comes over, and that 1 comes over. That's going to be a positive y and a what? Minus 1. Factor out a y prime. So y prime is equal to y minus 1 over 3y squared minus x. Now, if I was a booger, I'd make you do the second derivative. But contrary to what y'all believe, I'm a nice guy, so I'm not gonna ask you to do that on the test because you'd be pulling your hair out. question, gripe, complaint? Okay, I have just finished what I consider important problems in 3.8. So that means everybody should be working on those sections up to 3.8. I don't know what I'm going to cover next. Everybody with me? I don't know what I'm going to cover next, but I guarantee you this. It will be a different homework. I'm going to do homework on my own from here on out. Okay? So do not do any homework in the others chapter 3 areas that I haven't put dates on. Let's see what those are. Which I don't think I got to worry about this class going ahead. I can't get some of y'all to do homework from 5 weeks ago. So right now, y'all should only be doing problems that have dates on them. Come on. I won't hit chapter 3 right here. Y'all know y'all can do this too. It's a miracle. So I don't need you to work on 3.6, 3.8, 310, or 311. We will go over some of those problems, but I'm going to go through and pick out. I know some of y'all have done maybe some, I don't know, but I'm going to go through and pick out. I'm going to pick out the bogus ones and kick them out. I'm going to kick them out. Or I'm going to redo this homework. If I redo the homework and you've done some, I can either take those points over or I'll look at the points and see. If it's below a 50, I'm just going to let you decide. If it's above 50, I'll carry it with it, or you know, I don't think anybody's done anything, but I'll look and see. The whole point is y'all need to be focusing on these, what, 7, 1, 2, 3, 4, 5, 6, 7. And you really need to be focusing on these 5 right there. That's the ones you need to be focusing on. As long as you can do the difference quotient up here, that's all that matters. Who's got questions on that so far? Somebody ask a question. Hold on. I have A's on all the daily homework. Carry them up. All right, so you want me to just carry all your A's over to the other homework so you don't have to do them? Okay. Miss Hart, I know you're not being serious. You want to get your money's worth out of this course, Miss Hart.
But I'm all about some extra free points too.
I understand. Okay, I'm going to go ahead and shut down the recording and turn off the presentation so I can take the roll.